device? Yes. I have in fact returned to 0057 alpha. This is pseudonymous. I'm coming back out of retirement, and for today I will be doing a physical demo and a magic trick to make the explanations of quantum mechanics sound easier to understand. This is me coming back out of retirement slowly. Also, pardon the cat ears, I'm finally reabsorbing some of my observer heritage. Anyway, let's see if these demos make the explanations seem easier. As per usual, all demonstrations or documentaries that I film will be filmed from the memory perspective directly from my eyes and ears and uploaded first to the Hypersphere network to return to Universe Sector 001 and also to YouTube afterwards in 0057 alpha via way of my contact to allow other people to view what we're recording. This is going to be a demonstration of quantum teleportation using two randomly shuffled decks of cards, a D10 which will tell us how many times to roll this D6 so that we get a number between 1 and 54 to select a card between both decks, since with both jokers, each deck has 54 cards if you treat each joker as a separate entity. So, first things first, I will take this out and just show you it is a completely ordinary random deck of cards. Move that off to the side there. Now what I'm going to do is I'm going to do a couple of, I'm going to get down to there, do a couple of randomly quick shuffles here. Move the other deck out of the way. Okay, there's one. Do a quick random shuffle, give it a quick cut. So there's one. Oh, damn it, cards are flying away. 1 second. Stay put, stay put. Hold that there. Now take the second deck, put that box there, and while I move this deck here and have it pinned by the dice so it doesn't fly away, I will randomly shuffle the second deck. No, stay put, stay put. Okay, there we go. Randomly shuffle this deck, and with any luck, we'll put it together here. Okay, there. Now, first, we're going to put these, what we're going to do is we're going to put these decks back in their boxes, so that this way cards don't fly away while I'm doing the dice roll. Hang on, there's one. One more. There's two. Okay, now we roll the D10 to see how many times we roll the D6. Okay, that is a 10, so we will roll the D6 once and then transfer the card. 1. Okay, so today we are doing the top cards off each deck, and then we are going to shuffle both decks to lose the card. So there's the top one for the red deck and the top one for the blue deck, and we switch them over. And now we give these guys a quick shuffle just to lose the cards inside the deck. 1 second. Okay, now here's the weird part. We have done a quantum teleportation of a red card to a blue deck and a blue card to a red deck. Now the odds of picking the exact same card from both decks are 1 in 54 squared, or odds of 1 in 2,916. So now let's go to the cards and see what we have found. Hang on. Keep going. There's the red card from the blue deck. And the blue card from the red deck. And at the count of 3, we'll flip them and see if they match. 1, 2, 3. Both decks were, as we said with the last clip, both cards were 3 of diamonds, and thus both decks were entangled. This is the living entanglement trick, a demonstration of quantum teleportation using cards. Okay, so this demo is supposed to show that quantum entangled particles are in fact connected, and there is energy and information flowing between them. Now, just as a reminder, which will have links in the description, They have made analog black holes in the laboratory, which means making analogs of quantum experiments should also follow the same precedent. So here's what we're going to do. First, I'm going to start these two countersinking. Now, as they're countersinking, I'm going to put a towel over top to demonstrate quantum uncertainty. You don't know if they're spinning in or spinning out. But if I lift partially and you see only one spinning in or spinning out, you instantaneously know that the other one countersunk is at the exact same position on the opposite side. You can also verify the EPR equals ER connection, where quantum entangled particles are verified by a wormhole, by just simply removing the thing and having something like a coin or information transfer pass through, thus demonstrating that these things are in fact connected. Also, two other indicators which show that entangled particles are connected in this way. One, in quantum field theory, correlation coefficients are also called propagators or energy transfers, and a recent paper in Physical Review Letters also showed that the lower bound of speed on information transferring between entangled particles is approximately 10,000 times the speed of light. Again, links in the description of this video once it goes to YouTube, of this report once it goes to YouTube. And just as one other thing, since these particles are exchanging, we can also verify by torsion balance that gravity and quantum entanglement may in fact be linked. Anyway, on to the final thoughts. So, that's two memory reports of using macroscopic phenomena to explain quantum phenomena in a way that hopefully will make things easier for people to understand. I hope you in 0057 Alpha enjoyed these memory reports being attached to this video on YouTube, but I have to return to my home universe. And as they say, have a good one, guys. Addendum to this memory report from me, Pseudonymous. A paper recently came out in 0057 Alpha called Microscopically Non-Local Quantum Correlations, which said that if you want to look for evidence of quantum non-locality or entanglement on the macroscopic level, you need to look for deviations from Gaussian or normal distribution. This is why several of the previous videos in the Observer Report playlist have been measuring of chi-square scores on random number generators. We are looking for non-normal distributions in the random numbers, hopefully demonstrating some sort of quantum non-local influence. Anyway, hope you enjoyed this report, and I'll see you next time.